Imagine a night where the sky gleams so beautifully in the dark, casting an enchanting glow. If you looked at the sky close enough earlier this year, you may have actually seen this spectacular phenomena, which is known as the Aurora Borealis. This occurred as a result of strong geomagnetic storms. These storms aren't the type you typically expect here on Earth's surface that bring extreme weather. Instead, these storms that come from the sun help bring an extraordinary light show to our planet.
Aurora is excitation of the atmosphere by electrons and protons coming in from space. When they come in, they collide with the atoms and molecules in the upper atmosphere, and it excites the valence electrons to higher levels, and after a short period of time, those valence electrons decay back down to the ground state and emit light. So what you see in the aurora is just the atmosphere glowing, kind of like what happens in a neon light. The electrons going through the tube of the neon light collide with the neon and it glows.
Even though these electrons and protons may create some stunning light shows, not every solar storm will cause an aurora. This is because the sun's activity is challenging to pinpoint. Coronal mass ejections, known as CMEs, are the main cause of solar activity that lead to auroras in Earth's sky. They are large explosions of plasma on the outer layer of the sun. These can travel to Earth anywhere within 15 hours to even several days. Once these CMEs arrive, geomagnetic storms occur, sometimes causing auroras. The speed and size of the CMEs determine how far and for how long we can see these colorful occurrences. Although CMEs are a main factor in seeing the northern lights, it does not affect everyone equally. This is because Earth's magnetic field attracts charged particles closest to the poles. In the continental United States, there is less attraction for charged particles compared to the north and south poles. While the northern lights are sometimes visible here in Pennsylvania, they are more likely to be seen the closer you get to the North Pole. Geomagnetic storms were historical this year, making them viewable from 5 different continents, including here in North America. According to the Space Prediction Center, the strongest geomagnetic storm in 20 years occurred this past May. The northern lights were spotted as far south as Hawaii for the first time in over a century. While this was quite rare, solar activity reached higher levels than modeled. Since we are near the peak of a solar cycle, seeing these phenomena will be more common over the next couple years.
The time you'll most likely see large storms is near solar maximum and after solar maximum. So definitely you can expect over the next couple of years more storms.
In order to see auroras, skies must be dark and mainly clear. To get the most of your viewing experience, find an area away from enhanced light pollution and look to the north and near the horizon. The closer to the North Pole you are, the better the chances of seeing these dancing lights. During these spectacular shows, the human eye can see the scattering of many different colors, including pink, green, and blue throughout the sky. We see these colors from the human eye because of interactions between excited atomic particles of oxygen and nitrogen. If you're having trouble seeing the color during an aurora, it can be seen through an exposure camera, as it adjusts better to the natural night light than an ordinary camera. And even if you don't have a professional camera, most of today's smartphones have an exposure camera and will do just the trick. You can refer to the Space Weather Prediction Center for the latest details on space weather. If the forecast looks good for auroras, grab your cameras, find a dark spot, and take in that magical display. For Weather World, I'm student meteorologist Matthew Howard.